Alright, we've been running the system for about 20 minutes. We were getting 115 degree air temperature out. We were only drawing about 1.8 amps. And we're going to add 2 more tablespoons of electrolyte. Try and raise the amp rate a little bit and try and build up more HHO production and get some more heat out of the system. So now I'm going to add 2 more tablespoons. Put the cap back on, make sure the cap's tight, and then we're going to start the system back up and run it. Increase our amp rate, increase our hho production, and raise the temperature. Cap's on tight. I'm going to flip the switch on. I'll wait for that thermostat to come on.
And there's going to be air in the lines for a minute, so we might not get a flame right away.
Yep, we've opened up the system and let all the HHO out, so now we're going to... Thermostat saying it's 88 degrees in here, and we have it set on 80, so I'm going to run the temperature up. 92, make sure the system comes on. Bleed some of the air out of the lines. Sparking and flame lit.
I don't know if you can see the flame or not.
The system's going to run a little bit longer and it's going to build a bigger flame.
And right now our amp rate is so.
Now that's the amp rate on the 12 volt side from the cell.
This is our production.
And right now on the main power going to the system, we're running 197 watts, 199, and it is drawing 1.66 amps, 1.7.
And that's at how many volts? Are we at?
That is at 118.8 volts. Right now it's drawing 1.70 amps and 204, 205 watts.
Okay. And our temperature up here, explain why we have the temperatures that we have here on this.
That's telling us it's 88 in here, 88.5, and we have a probe going up to our heat exchanger. And that's just monitoring the bottom of the heat exchanger right now. It's saying it's 103.2.
Amp rate's doing a little better, about halfway through. And explain why we always keep this valve closed.
This valve's closed because we don't want any flashback coming down through here, and also to keep any of the gases going out of the torch tip and not coming back down into the tank.
Okay.
We're going to keep that valve closed until the system's off. If we notice a lot of condensation and moisture built up in this hose here, once the system's shut down, we'll open that valve and drain it back into the tank, and then close that valve again before we relight the system.
Looks like our amp rate's going up a little bit here on the 12 volt side. If you can see the flame, I don't know if you can see it any better in the picture.
The flame is getting a little bit bigger.
Of course, that flame is hitting this block, which is heating the water that's going through it and running it through that radiator. And I'll point out too that the fan is running.
Yep. From when we had the system on before, the heat exchanger block here, we have this snap switch set at about 115 degrees. That's the temperature there that the fan's going to come on. That's monitoring the inside temperature of this heat exchanger. So right now it's saying the inside temperature of this block here is 115 degrees, and our 12-volt fan on the front of the cabinet is running.
A little better production there.
Yeah, we've increased our HHO production a little, and the amp rate on the 12-volt side is running about 15. We were only running probably 7 to 10 before we added 2 more tablespoons of electrolyte.
And what's the...
You're running 198 watts, 110 side going into the system. It's drawing 1.70 amps at 118.8 volts.
We'll continue running here and have another video here so that we don't have to sit here for 10 hours and watch this. We'll come back with some more videos as this goes. Where are we at right now?
198 watts. 1.69 amps at 118.9 volts.
And we're getting this kind of flame that's heating the water going through that block, running to the radiator, back through the pump, back out the pump, and continuing the cycle. More in a